Good morning, grade fives. I'm really excited because my roommate has told me that I can have the other muffin. Hooray! But he did say that I can't eat all of it. He told me I could either eat 1/3 of it or 1/4 of it. I'm not sure which one to have. I know I want to have as much of the muffin as possible, but I'm not sure which one is more, 1/3 or 1/4. That sounds like it's really important for me to know if I want to get as much muffin as possible. Okay, so let's take a look at a lesson that shows us which one's more, 1/3 or 1/4, and shows us how we can figure out which fraction is more than another. Once I know how to compare fractions, then I should be able to figure out how much of the muffin I can eat. If we want to solve the muffin mystery, we first need to figure out how to know which fraction is greater and which fraction is less. So let's jump right in. I've got two pies here, one on the left, one on the right, and the one on the left is 1/4 of the pie left, and the one on the right is 3/4 of the pie left. Well, which one's more? Well, the one on the right, the 3/4, is clearly more pie. But is that always the case? Is 3/4 of a dollar more than 1/4 of a dollar? Is 3/4 of an hour more than 1/4 of an hour? Yes, it is. So I think we can make a general rule. If we are comparing 1/4 and 3/4, 3/4 is always going to be greater. So here's our greater than, lesser than sign, and you can see that the open end is always pointing towards the greater number, because we know that the hungry alligator is always wanting to eat more pie. Okay, so 1/4 is less than 3/4. Let's look at some examples for you to try out. So I'm going to let you press pause, but before I do that, I guess I have to explain what I want you to do. You can see there are some fraction lines and some circles. For the fraction lines, I just want you to write what each fraction represents, what the colored in part is. And then for the green circle, I want you to imagine which one is greater than or which one is less than, using those open-ended triangle signs that we looked at on the previous page. So press pause and then press play when you're ready to see the answers. Welcome back. Okay, let's check your answers. So starting with the golden ones on the left, there are two rectangles and they're both divided into the same number of equal parts, and that is 5 equal parts. But they have different amounts shaded in. The one on the left has only 2 shaded in, and the one on the right has 3 shaded in. Okay, well, which one's more? Well, it looks like the one on the right has more shaded in. Yeah, so I'm going to say that it is greater, which means that 2/5 is less than 3/5. Okay, let's look on the right with the blue rectangles. Okay, so how many equal pieces is it divided into? Let's count. 1, 2, 3, 4, 5, 6, 7. They're both divided into 7 equal pieces. So let's put 7 as the denominator. What about the numerator? Well, the one on the top has 2 shaded in, so 2. And then the one on the right the one on the right actually has more, it seems. It has 3 shaded in. So which one has more of the rectangle shaded in? That seems pretty obvious. The one on the right does. So we're going to have our open alligator mouth pointing towards the greater fraction, which is 3/7. Okay, let's look at the green ones on the bottom. Again, they're both divided into 7 equal pieces, but they have different amounts colored in. The one on the top has 1, 2, 3, 4, 5 colored in, whereas the one on the bottom only has 1, 2, 3, 4 colored in. Which one has more colored in altogether? It looks like the one on the top is a greater fraction, so 5/7 is more than 4/7. Do you see a pattern here? If not, I'm going to drive it home with some more pies. Okay, so on the left we have 1/4 and 2/4, and 1/4 is always less than 2/4. And on the right we have 1/8 and 2/8, and 1/8 is always less than 2/8. And on the bottom we have 1/6 and 2/6, and 1/6 is always less than 2/6. Oh gosh, I have trouble saying that. Sixth. There's a tongue twister for you. So is there a general rule here that we can say about these kind of fractions? Yes. Yes, there is. And the general rule is this. If the denominator is the same for two fractions, the fraction with the larger numerator is going to be greater. Why? Well, because there are more of those equal pieces. So, if I'm looking at two sets of equal pieces, two equal pieces of the same size is always going to be more than one equal piece of the same size. So let's apply that with an example of sorting. Well, it asks me to sort these fractions from least to greatest, and they all have the same denominator, so all I need to worry about is the numerator. Which one has the least number of pieces shaded in? Well, that would be 2/7. It has the smallest numerator, so let's move that to the beginning. Okay, then what? Next lowest digit is 4, and then the next lowest digit is 6. No, it's not. Fooled you, it's 5. And then finally 6/7. Okay, so 2/7, 4/7, 5/7, 6/7 from lowest to greatest. Okay, now it's your turn, and I'm giving you a challenge. The denominator is bigger and there are more of them, so press pause to sort them, and then press play to check your answer. Okay, welcome back. Because there are so many of these, I find it's going to be easier if I look at the one-digit fractions first and then the two-digit fractions. Well, they all have 21 as the denominator, but there are some numerators that have one digit. So let's work on those. That's 4, 8, 6, 5. And the lowest numerator, is 4/21. Yes, that's how you pronounce it. I looked it up. So let's put that for least. And then the next lowest number is 5, so 5/21. Then 6, so 6/21. And then 8, 8/21. Okay, we've dealt with the one-digit numerators. Time to look at the two-digit numerators. I think 11 is the lowest two-digit numerator, so there we go. Followed by 12. And finally 19. So if you got that right, give yourself a pat on the back. And let's look at a totally different situation involving some fraction strips. And in this case, you're going to have different denominators. How do we deal with fractions when there are different denominators? So, in this case, I have 3 different fractions. They all have the same numerator. One part is shaded in, but they have different denominators. They're divided into different numbers of equal parts. So we've got 1/2, 1/3, 1/4. Does anyone see a pattern? Yes, it seems to be decreasing in size each time. And why is that? Well, if you have one size object and you have to divide it into more and more equal pieces, each piece is going to have to be smaller. So let's make a prediction. If I'm trying to get 1/5, is it going to be smaller or bigger than 1/4? Okay, there's your answer. And if you said it's going to be smaller, you were right. Why? Because you have to divide it into 5 equal pieces now instead of 4 equal pieces. So each piece has to be smaller. Okay, what about 1/8? Would it be more or less than 1/10? 1/8 would be more than 1/10. Why? Well, if you were to take 1/10, you'd be dividing the piece of paper into more equal pieces, which means that each piece would have to be smaller. So 1/10 is going to be smaller than 1/8, which means that 1/8 is more than 1/10. So what's the point I'm trying to make here? Well, the point I'm trying to make is that 1/2 is always going to be more than 1/4. But wait, you say. Here are 2 fraction strips. One is 1/2 colored in, one is 1/4 colored in, and clearly the 1/4 is a larger colored in piece than the 1/2. What's going on? Was I lying to you? Is all of math a lie? Is all of life a lie? No, don't panic. I just forgot to tell you one important thing, which is that when you're comparing fractions of a thing, the things that you are comparing have to be the same. If both fraction strips are the same size, then 1/4 would be smaller than 1/2. But these fraction strips are not the same size. And so when you're talking about comparing fractions, you need to imagine that you're comparing fractions of the same amount or the same thing. So yes, 1/2 of a house is going to be smaller than 1/4 of a city. But that's because you're not comparing the same object. When we're talking about fractions being larger or smaller than each other, we're imagining that we're comparing fractions of the same thing or the same amount. Okay, so with that in mind, let's look at some questions for you to solve. Okay, so it's the same thing as I asked you to do before. You have to figure out what the fractions are and then decide which is greater, which is less. Press pause and then press play when you're ready to check your answers. Welcome back. Okay, starting with our golden fractions. Well, you can see that in both cases, 3 pieces are shaded in. So let's put 3 for the numerator. But the denominator is going to be different because they are divided into different numbers of pieces. On the left, it's divided into 7 pieces, and on the right, it's divided into 5 pieces. Okay, so which one looks like it has more shaded in? Well, to me, it looks like the one on the right is shaded in more, so I've got my greater than, lesser than sign pointing open towards 3/5 because the hungry alligator wants to eat more. Okay, let's take a look at the blue ones on the right. Again, they both have the same number of pieces shaded in, and it is 3, so 3 for the numerator. But the denominators are going to be different. The one on the top is clearly divided into a larger number of equal pieces. 1, 2, 3, 4, 5, 6, 7, 8. 8 equal pieces. And the one on the bottom is only divided into 4 equal pieces. Which one has more shaded in altogether? Well, it looks like the one on the bottom has more shaded in. 3/4. So 3/8 is less than 3/4. Okay, let's look on the bottom. In this case, there are 2 pieces shaded in for each of the fractions, so that's our numerator, but the denominators are much different. The one on the top is only divided into 3 equal pieces. The one on the bottom is divided into 6 equal pieces. And which one has more of the rectangle colored in? Why, it's the one on the top. 2/3 is more than 2/6. So, what's the rule for this one? Well, the rule is this. If the numerator is the same in 2 different fractions that you're comparing, the fraction with the larger denominator is going to be less. Why? Because you have to divide the same thing into a larger number of equal pieces. So each piece is going to have to be smaller for each of the pieces to be equal. Okay, time to apply that to a sorting situation. Here are some fractions. The numerator is the same, but the denominators are different. I want you to order them from least to greatest. Press pause to figure that out, and then press play when you're done. Okay, welcome back. So remember, the number with the largest denominator is going to be the smallest fraction because you have to divide it into smaller size pieces in order to fit all of them in there. So the largest denominator that I see is 9, so that's our smallest fraction. Okay, what's next? Well, I think that 8 is our next largest denominator, so let's bring that over, followed by 6, and finally 4. Okay, we've sorted those fractions from least to greatest. Okay, so now that we understand how denominators and numerators change the size of the fraction, let's look back at my muffin and see if we can solve the dilemma of how much I should eat. Well, I think that was pretty helpful, and based on what I know now, I'm pretty sure that 1/3 is more than 1/4. Why? Because 1/3 means that you're breaking the muffin up into fewer equal pieces, so each piece should be bigger. So, I'm going to take my knife, I'm going to make sure I don't impale myself with the knife here, and I'm going to cut the muffin into 1/3. And thanks to my knowledge of fractions, I'm able to eat as much of the muffin as I possibly can based on the two choices that he's given me. So, I'm going to eat the muffin. I want you to complete page 203 in your Jump Math booklet, and also the online quiz that I've posted for this lesson. Enjoy your math. I'm going to enjoy my muffin. See you later.